Okay, in this video I'm going to demonstrate how to input and describe data for a single numeric variable in R. Specifically, we're going to focus on creating a vector of scores and obtaining descriptive statistics for them. So the example is going to utilize a variable called quiz scores, and what we have right here are 12 observations, or basically 12 quiz scores from a set of students. And we're going to first create our vector of scores using this command line right here. And looking at this, and in terms of inputting data, notice that we have quiz score. This is the name of what's called our data object. So basically, when you're working with R, you're going to be working with different types of data objects. Sometimes you'll be working with vectors, sometimes with matrices, sometimes with data frames. And really, under most circumstances, when you're working with multiple variables, you're going to probably be working with data frames. But learning about how to input data using vectors is a good starting point. So the name of our vector we're going to call quiz score. And so whenever you're naming your data object, it's a fairly arbitrary process. There's no specific requirements or anything like that with respect to how you're actually naming it. So that's why we're just basically calling this quiz score. You'll notice that we have a less than sign and a hyphen that's basically forming a little arrow here. And you'll notice to the right of the arrow we have what's called a C function, and then inside the parenthesis you'll see the values on our variable separated by commas. So when you're entering data directly in this kind of way, you're going to be utilizing the C function, and inside the parenthesis you'll have the values on the variable separated by commas. So this is a fairly simple vector that we're working from, and we can generalize this even further and make it more complex later on, but not so much for this video. So let's enter the data into R. So what I'm going to do is go into R, and I'm going to type in quiz score, which is the name of my vector, then type in my less than sign and a hyphen forming that arrow, and then type in C, and inside the parenthesis I'm going to type in the values that we just saw separated by commas. So we'll type in 70, 85, 88, 80, 93, 87, 71, 69, 95, 89, 92, and 100. Well, we also have to have an in parenthesis here, and then we hit enter. And so there's no error or anything like that. At this point, we just entered the data. If we want to take a look at the data, we can type in quiz score, hit enter, and there's our data. If we want to look at the structure of the data, then we can also use the str function, or structure function. So we'll type in str, and inside the parenthesis we'll type in quiz score, and in parenthesis, and hit enter. And so you'll notice, looking at this, that the structure of our data, it's a numeric variable basically, 12 observations, and then these are individual observations that are appearing in our vector. So the structure function is really useful when it comes to looking at characteristics of your data. Different functions in R make certain assumptions about the characteristics of your data, such as, is it numeric, is it a character data, or is it factor level data, that sort of thing. And so when you're running various analyses in R, if you're using a function that makes a certain assumption about the characteristics of your data, if the characteristics don't match up with the function, then you can end up with error messages that can be pretty frustrating. So this is also a useful function in order to sort of diagnose potential problems. So there you go. So at this point, one other thing to note too is that I kind of typed all this in on the same line, and what I'm going to do really quickly is just show you what happens. Let's say that I didn't incorporate the in parenthesis here. So I'm going to type in quiz score, and my little arrow here, and I'll just type in everything as it was before, and then just not incorporate the in parenthesis, just to show you what happens. So we'll type in 75, 70, 85, 80, 93, 87. Oh, excuse me. I kind of missed one right here. That was 88, 80, 93, 87, 71, 69, 95, 89, 92, and 100. If I hit enter, you'll notice it goes to the next line and there's a little plus right here, and that's basically saying you're not done yet. So if I had more to add, I could certainly do that, or if I just want to end the command, I can just type in my end parenthesis here and hit enter, and it's all set. So again, if I just take a look at the structure, you can see it's exactly the same as it was before, 12 observations and so forth. So this is pretty handy, particularly when you have lines that are really long, knowing that you can just kind of continue the commands on to subsequent lines. So at any rate, let's look at some of the functions for obtaining descriptive statistics. So what we have right here, we have mean function, standard deviation function right here, which is SD, median function, min function, and so forth. So the thing to note is that when you're working with different functions in R, the function is essentially being used to operate on a data object. So you'll notice that in this case, mean, we have quiz score, and so it's basically saying generate the mean for our quiz score vector. SD is being used as to generate the standard deviation for quiz score and so forth. So let's walk through some of these. I'm going to type in mean and then quiz score inside parenthesis. We'll type in SD quiz score inside parenthesis. We'll type in median quiz score. We'll type in min quiz score, which in this case is going to give you the lowest value in the data set, max quiz score, which is going to give us the highest value. Range is basically going to give you the minimum and maximum values all at once. So you can see that we've kind of gone through and done sort of a piecemeal approach to looking at different aspects of our data. Shortly, I'll kind of go over a little bit quicker approach to obtaining this and other information. But the next thing that I want to highlight is that we can also describe our data visually using histograms and kernel density plots. So if we want to generate a histogram of our scores, we can use the hist function, H-I-S-T, and then we can type inside parenthesis quiz score and hit enter, and there it is. So now you can see that we have a histogram. You can see that the bars are basically representing intervals of values on our variable quiz score, and along the y-axis right here we have frequency counts that are represented. So we can also, if we wanted to rename or retitle this right here, you can see that right now this is the default title. If we want to retitle it or whatever, we can do that using the main argument. So we'll type in hist quiz score and then comma main equals, and then we can inside quotation marks we can type in the new title. So I'll call this histogram of student quiz scores in quotation marks in parenthesis. So when I hit enter, you'll notice that now this is the title, so it matches what we've just typed in right here. So at any rate, just kind of notice that in this case we have our data object that's being reflected, and then we have another argument, which is the main argument, which is basically being utilized to create our title. So right now, most of what we've done is we've focused in on sort of one argument, if you will, that's contained within the parenthesis, but many other functions incorporate multiple arguments that can be included to accomplish various aims. So let's say that I want, instead of using frequencies, I want densities associated with these intervals. So I can also type in hist quiz score. I can still type in main equals, and I can still stick with what I had before, histogram of student quiz scores, comma, and then use the FREQ, frequency argument, and I can type in either true or false. If I type in true, what I get is the exact same thing as what I'd had before. So the default argument for the histogram function is essentially utilizing frequencies along the y-axis. If I set this for false, then I get densities along the y-axis. So this is it right here. So that's essentially how you can go back and forth between frequencies and densities. But notice that this is a logical uh, um, statement, a logic statement. Basically, it's either true or false. Notice it's in all caps. So that's how you basically set it up in R. So at any rate, the next thing I want to show you is how to generate a kernel density plot. So you can see right here that everything kind of looks kind of boxy and so forth, and so you can get a general idea about the distribution of scores. If I want a smoother distribution, I can generate a density plot. And so so what I'm going to do is first I'm going to show you how to use the comment function or use create comments in R. To do that, I can just use a pound sign and then follow it up with a comment. So following or creating a comment. When I hit enter, you'll notice that nothing occurs, but it's just basically giving, I can basically create comments in my syntax. If I typed in just creating a comment by itself and hit enter, then you can see that you get an error. So anytime that you want to comment, you have to start it off with a pound sign. So I'm just going to create a kernel, I may have misspelled that, but anyway, kernel density plot. And so I'm going to create this. And so first off, I'm going to create a data object that I'm just going to call densities. So with an arrow pointing to this. So this is just my naming of a data object that's going to contain the densities. So then I'm going to use the density function and then type inside parenthesis quiz score and hit enter. And so now I have a data object that's created, and if I want to plot it, I can just type in plot densities and hit enter, and there you go. So this is the density plot I was telling you about. And so you can see that it provides a much smoother representation of the data. So at any rate, those were just the hist function, the plot function. These are useful for coming up with graphical representations of your data. Now, I mentioned earlier about that each of these functions, like the mean, standard deviation, median, and so forth, we utilize all of these in sort of a piecemeal fashion. Another way of generating descriptive statistics that can be really handy and a lot quicker is to utilize a package that's been written by a user specifically to incorporate sort of a collection of functions. So in many ways, these packages will incorporate sort of defaults that will give you various pieces of output. It's very similar to what you get when you're using sort of menu systems like in SPSS or Stata, where when you're using a menu and you generate, say, descriptive statistics or whatever, a number of those systems are already, sort of incorporate a collection of functions, if you will. So with R, users oftentimes will contribute packages that they write that incorporate various functions, and they can accomplish a lot of different aims both more quickly and just give you a broader range of options when you're analyzing your data. So what we're going to start off with as a demonstration is the use of the package psych. Now, the first thing that you're going to have to do, if you haven't already installed the package, you're going to use the install packages function. So it's install period packages. And then inside the parenthesis, you're going to type in quotation marks, and inside the quotation marks, you're going to have psych. So basically, what I'm going to show you really quickly is how to use the install packages function. So I'm going to type in install period packages, and inside the parenthesis and inside the quotation marks, we'll type in psych, end quote, and end parenthesis, hit enter. And so now you can see that we get this comes up where it's asking you, hey, where do which mirror site do you want to install the package from? So so typically you're just going to pick whichever site is probably closest to you. So I'm just going to pick Texas, I live in Oklahoma, so I'm just going to pick Texas and click on OK. And so now you can see the program is installing the psych package. So at this point, we're just about ready to use the package. And the function that we're going to be using is the describe function. So it's essentially, kind of looking at this right here, we're using this function right here that's going to generate a collection of descriptive statistics. But the thing is that after you've installed the package and you're ready to use it, you have to make sure that it's called up into R. So we use the library function call up the package before we can use it. So you don't have to keep reinstalling the package over and over again. It's already installed in this particular case. But if I haven't called up the package for use with my data, for this data or any other data, then I have to do that or else I end up with error messages. So you'll notice really quickly, if I just type in the describe function, if I type in describe and then type in the name of our vector, quiz scores, you'll notice that it says could not find function describe, and that's because the describe function is associated with the psych package. So for me to be able to use this, I have to basically call it up. So I'm going to use the library function and type in psych and then enter, and so now it's ready to go. There's a little warning message just telling you where, what version of R the package was built under, but it's okay. So now I can use the describe function. And so now you can see that I get various descriptive statistics. So you'll see that I get the sample size and there's my mean, standard deviation, median, there's a trimmed mean right there. Minimum, maximum values, range, skew, kurtosis, there's a standard error. So all of that, all of these would be individual functions that that I could theoretically walk through in a piecemeal fashion, but why would I want to do that if I can get it all at the same time? So another package that we're going to talk about is, excuse me, the paste CS package, I guess you could say. So we're going to install this package and utilize the stat period DSC function. So in this case right here, we're going to use install period packages. Inside quotation marks, we'll type in the name, and then in quotation marks, and then hit enter. So now again, we're going to install that. And so if I want to use this, I have to use the library function. So I'm going to use library paste CS right here. Notice that I'm not using quotation marks here, but you do have to use quotation marks when you're using the install packages function. So now we're ready to go, and I'm going to use the stat period DESC function, and we'll type in quiz score again, for that's the name of our vector, and hit enter. And so now you can see that we get a number of values, minimum, maximum values, range, sum, median, mean, standard error of the mean, variance, standard deviation, and so forth. So that pretty well covers sort of an introduction to, as I said before, the creation of a vector of scores and how to generate descriptive statistics for that vector.